Hi, I'm Greg from Emesent. Today I'll be showing you how you can capture Hovermap with 360-degree panoramic images. 360-degree images help add valuable context when capturing Hovermap data, allowing you to derive new insights. Today we'll be capturing this cycle and pedestrian tunnel where the 360-degree images will help with detail and precision when modelling using the data. Okay, I've got my Hovermap powered on. I've got my 360 image telescopic mount attached to my Hovermap handle and my GoPro Max camera attached to the mount. I'm going to open up the Commander app and start the scan in Commander. While the Hovermap's starting up, I'm also going to start the 360 video recording and fully extend the mount. I'm going to leave the Hovermap about 10 seconds to start up. And I'm going to do about a 60-degree rotation of both the Hovermap and the camera, and that helps with the alignment and synchronization between the IMU in the camera and the Hovermap. Now I'm ready to start scanning. I'm going to keep the Hovermap and the camera in a consistent position while I'm scanning so that it's easy to mask myself out later on in processing. I'm going to make my way back to where we started to close the loop. Now finish the scan, going to stop the scan, my Commander app. Also stop the recording. Now we can head back to the office to process the data. I'm now back in the office and I've offloaded my Hovermap scan and transferred the 360 video file into the Hovermap scan directory. I'm now in Aura and I've already processed this dataset with SLAM, so now I'm going to choose to extract 360 images. I'm going to select the raw dataset and I can see Aura has successfully found the 360 video. I'll hit save. Next I can choose a profile. I'm going to select the telescopic mount extended profile as that's how the camera was mounted when I captured the data. But you'll notice here there's an option to use the calibrated 360 camera mount. And that's a great option, particularly for drone, vehicle or backpack scans. And because it's calibrated, it will deliver a finer alignment between the point cloud and your 360 images. I'm going to jump into processing settings. And here I have the option to choose how frequently frames or images are extracted. I'm going to change the default from a frame every 1 meter or 45-degree camera change to every 3 meters, as my pedestrian and cycle tunnel is a pretty simple environment. I don't need lots of images. Here I'll see the camera orientation is already defined based on the profile and mount that I've selected. I have the option here to mask myself out of the images with using one of the built-in masks or creating my own mask. For this demo, I'm not going to use masking. I'll hit save. Now I can choose my output name and hit start to start processing. Now that my processing job is finished, I'm going to bring up the point cloud of my cycle and pedestrian tunnel. And to view the 360 images, I can click View on the finished processing job, or I could open up the frames.json file in the output folder. You can see now I have my 360-degree image capture points, which are geolocated alongside the point cloud. I can toggle on and off the capture points on the left-hand side here. And to jump into the 360 image view, I can click on one of these capture points. The 360 images are located behind the point cloud, so I can adjust the point cloud opacity to view more of the 360 images. And in 360 image view, I can zoom in and out of the images using the mouse wheel. I can jump between the capture points by clicking on the next one when I'm in 360 image view. And I can also adjust the opacity as I go. To leave 360 image view, I click the cross button at the top right hand side. Thanks for watching this video. If you want to learn more, please visit the Emesent website.